Hello and welcome to another GCSE revision video, and in this video we're going to be looking at some technical terms related to probability. Okay, the first of our technical terms is mutually exclusive events. Now, the probability of passing a test and the probability of failing the same test are mutually exclusive. Two events are said to be mutually exclusive if one event happening makes it impossible for the other event to happen. In mathematics, we abbreviate the word probability to P. Rather than typing or writing out the name of an event multiple times, we can just assign a letter to that event. Mathematically, we say that A and B are mutually exclusive if the probability of A and B is equal to 0. Another example of mutually exclusive events: a number is chosen at random. What is the probability that the number will be both even and odd? Obviously the probability is 0. If a number is even, it can't be odd. If it's odd, it can't be even. Another technical phrase is collectively exhaustive events. Two or more events are said to be collectively exhaustive if one or more of the events must happen. Mathematically, we say A and B are collectively exhaustive if the probability of A or B or both is 1. For example, the numbers 2, 3, 4, 5, 6 and 7 are written down and placed in a bag. One number is chosen at random, so we let A be the choosing a prime number as our event, and we can let event B be choosing an even number. So the probability of event A or event B or both is equal to 1, and you might want to remember that the number 2 is both even and prime. It is possible for events to be both collectively exhaustive and mutually exclusive, in which case the probability of A or B is 1 and the probability of A and B is 0. For example, the probability of tossing either a heads or a tails on a single coin toss is 1. The probability of tossing both a heads and a tails on a single coin toss is 0. Okay, we've been using words like and or fairly liberally just because they're regular words that we use in the English language, and we pretty much all know what these words mean. But in probability, words like and or have very special meaning. Because the meaning of and or is so very important in probability, I'm going to take some time to explain why it means what it means before actually telling you what it means. I toss a fair coin and throw a fair die. What is the probability that I roll a 6 and toss heads? Let event A be tossing a fair coin and it landing on heads, and let event B be rolling a fair die and it landing on a 6. Here's a table showing all the possible outcomes. So we've got our rolling a 1, 2, 3, 4, 5, 6 as our column headings, and we've got our tossing a heads or a tails as our row headings. There are 6 possible outcomes from rolling a fair die, and there are 2 possible outcomes from tossing a fair coin. So our table is a 6 by 2 table which has 12 elements. That is to say, we can toss a heads and roll a 1, toss a heads and roll a 2, and so on all the way up to tossing a heads and rolling a 6. Or we can toss a tails and rolling a 1, tossing a tails and rolling a 2, all the way up to tossing a tails and rolling a 6. Okay, so there's only one element in the entire table where we can get both a heads and a 6, and that is in the column 6 and the row heads. So our combined event then is 1 times 1 equals 1. Of course, there are 6 possible outcomes from rolling a fair die and 2 possible outcomes from tossing a fair coin. So our combined sample space then is heads and 1, heads and 2, heads and 3, heads and 4, heads and 5, heads and 6, tails and 1, tails and 2, tails and 3, tails and 4, tails and 5, tails and 6. Man, I really should get someone to do a Nightcore version of that. Okay, so our combined probability, or our combined sample space rather, you might know from multiplication, is that we can just multiply the number of rows by the number of columns to get the entire sample space. So that's 6 times 2 equals 12. So our combined probability then is our combined event, which is 1 times 1 equals 1, over our combined sample space, which is 6 times 2 equals 12. And if we remember how we multiply fractions... What do you mean don't remember how to multiply fractions? Alright, never mind. To multiply fractions, we just multiply the numerator and multiply the denominators. So 1 times 1 over 2 times 6 can also be rewritten as 1 over 2 times 1 over 6, which will be 1 over 12. So this finally brings us to what we actually mean by the word "and" in probability. So the probability of event A and event B means the probability of event A times the probability of event B. So when on a maths exam you see the word "and" on a probability question, it's really asking you to multiply the two probabilities together. Okay, so now we know what "and" means. What do we mean by "or" in probability? So for an example, I toss a fair coin and throw a fair die. What is the probability that I roll a 6 or toss heads? Well, there are 7 ways our combined event can be satisfied, and I've tried my best to colour them in what my colourblind eyes think is green. So don't have a go at me if that's not green, but we've got, out of all of our possible combinations, we've got heads and 1, heads and 2, heads and 3, heads and 4, heads and 5, heads and 6, and tails and 6. So that's a total of 7 possible ways that our event can be satisfied. Of course, our sample space is still 12, and no, I'm not going to read every single one of them out again, but we can remember that that's 6 times 2 is 12. So our combined probability is the probability of tossing heads or throwing a 6 is equal to the number of outcomes that match our criteria, which we remember is 7, divided by the total number of possible outcomes, which is 12. So our probability is 7 out of 12, or 7 over 12. Well, when we were defining the word "and", we could actually define it fairly easily as we just multiply the probabilities. So is there a way we can just do a function on the probabilities? For example, could we just add up the probabilities to define "or" in probability? Well, there are 6 heads in the sample space and 2 6s in the sample space, which would make a total of 8 events instead of the 7 that we're looking for. The reason for that is because we've double counted the probability of both a heads and a sixes. So when we were counting up the number of heads and when we were counting up the number of sixes, the heads and six have been counted twice. So to compensate for this double counting, we must subtract the probability of both events occurring. So the probability of heads or 6 is equal to 1 over 2 plus 1 over 6 minus 1 over 12, which will be 6 over 12 plus 2 over 12 minus 1 over 12. Now we've got the denominators the same, we can combine the numerators, so that's 6 plus 2 minus 1 all over 12, which is 7 over 12, which now gets us the right answer. And that finally brings us to our official definition of OR when we're talking about probability. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So can we just add up the probabilities? Sort of, if we remember to subtract any overlap that we have double counted. So let's leave you with a question. What is the probability of picking a vowel from the letters that make up the word probability? I'm going to leave you to think about that one. If you can pause the video, and then when you're ready to see the answer, just press play. Okay then, so what is the probability of picking a vowel from the letters that make up the word probability? Well, our vowels are A, E, I, O and U. So the probability of an A in the word probability, I'm going to put that in inverted commas so we know it's not an event labelled A, it's actually the letter A, is equal to, well, we've got 1A here, so that's 1 out of how many letters in the word probability? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 1 out of 11. So there's a probability of an E which is equal to, how many E's are there? There's no E's, so that's 0 out of 11. And then the probability of an I so we've got 1, 2 I's, and then the probability of an O is equal to, oops, yes, you heard it from me first, the probability of an O is oops. So we've got 1 O, so that's 1 out of 11. And then the probability of a U there are no U's in the word probability, so that's 0 out of 11. For the purpose of this question, we are going to count the letter Y as a consonant. So the probability of picking a vowel from the letters that make up the word probability is equal to 1 over 11 plus 0 out of 11 plus 2 out of 11 plus 1 out of 11 plus 0 out of 11 minus the probability of a letter being A, E, I, O and U, which of course is 0, so we can say minus 0 out of 11, but we don't need to subtract 0 out of 11 because that really doesn't count. And also adding 0 out of 11 doesn't count either, because if you add 0 to anything it's not going to make a difference. So our probability is 1 plus 2 plus 1, all out of 11, which is equal to 4 out of 11. You did not hear me say 3. I did not say 3. I will deny it in a court of law. You cannot prove it. Oh wait, it's recorded. Yes, you can prove it. Right, so our probability is 4 out of 11. Another way we could check is just to have counted the number of vowels. So we've got 1, 2, 3. So I'll make that clear. That's 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 4 out of 11 is the correct answer. Okay, I hope that was helpful. And I'd like to wish you all the best with your revision and all the best with your exams. And I'll see you in another video.